So the topic of today's video is inscribed angles of circles. Our objectives: I can define and identify an inscribed angle of a circle, and I can understand the relationship between arcs and inscribed angles. Now, an inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. So if we look at our illustration, down here we have our angle in blue, and we see that the vertex is a point on the circle. And then we can see that both sides also have chords that are on the circle. And an intercepted arc is an arc that lies in the interior of an inscribed angle and has endpoints on the inscribed angle. So if we look here, we have the red intercepted arc that's clearly on the inside of the angle, and you can see the endpoints are where the inscribed angle comes in contact with the circle. So a theorem: the measure of an inscribed angle is 1/2 the measure of its intercepted arc. So we have our angle ADB, and we have our arc AB. So the measure of angle ADB equals 1/2 the measure of arc AB. So we look at an example. We want to find the measure of arc AC. We know the measure of angle ABC is 70 degrees. So to find the measure of arc AC, we take our 70 degrees, multiply by 2 to get 140 degrees. There we go. Okay, another theorem: if two inscribed angles intercept the same arc, then the two inscribed angles are congruent. So if we take a look here, we have angle ADB and angle ACB, and they both share arc AB. So because of that, we can say angle ADB is congruent to angle ACB, and we have that marked on our illustration. Okay, so we are told in this example that the measure of angle B is 44 degrees, and we want to know the measure of angle C. And if we look, we can see that both angle B and angle C share arc AD. So the measure of angle C is equal to the measure of angle B, and that is 44 degrees. Okay. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Another way to say it is, if a triangle is inscribed in a circle and one side is the diameter, then the triangle is a right triangle. So we see in our illustration we have a right triangle, and the hypotenuse is the diameter, AC, crosses through our center D. So we have a right triangle inscribed in a circle. So if we look now at this example, we want to find the value of our variables x and y. And again, we see we have a diameter, SU, crosses through the center of our circle. And so if we have that diameter, it's our hypotenuse of the triangle, it's the longest side. So we can say that this is a right triangle. So to find, we'll first find the value of x, because this is a right angle. So we set 3x equal to 90. Divide both sides by 3, and we get x equals 30. Now to find y, It's our hypotenuse. We have a right triangle, so we can use Pythagorean's theorem. We take 12 squared plus 9 squared equals y squared. 12 squared is 144. 9 squared is 81. We combine the two of them and we will get 225. That's equal to y squared. We take the square root of both sides and we find that y equals 15. Okay, one final theorem. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So that means the opposite angles have to add up to 180 degrees. So for this to be true, right here, angle X has to equal 180 minus 68. And that would make angle X 112. Oops, 12. Try that again. 112 degrees. And make angle Y 180 minus 104. Make angle Y 76 degrees. So now if we think about which types of quadrilaterals this will work for, a square has all angles equal to 90, so that will work all the time because 90 plus 90 is always going to add up to 180 degrees. A trapezoid will only work if it is an isosceles. Oops, that's isosceles trapezoid. Otherwise, if we had a trapezoid that looked, say, like this with our two right angles, that would not work because the opposite angles would not necessarily be supplementary, because we'd have two 90-degree angles and the other two we know are not going to be 90. A parallelogram could be, we'll say, sometimes, and that occasion is if we have a square, which is a parallelogram, and then the same goes for a rhombus. And again, that special case is when the rhombus has four congruent angles or four right angles. So if we look at this example, we want to find the values of x and y, and we know that opposite angles have to be supplementary. So the value of our value of angle x, which is y degrees, y equals 180 minus 80. So y equals 100 degrees. And so then angle w, which is x degrees, we set x equal to 180 minus 85, and we get x equals 95 degrees. Okay, to review, we have all our theorems. Measure of an inscribed angle is 1/2 the measure of its intercepted arc. If two inscribed angles intercept the same arc, then those angles are congruent. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter. Another way to say it, if a triangle is inscribed in a circle and one side is the diameter, then it is a right triangle. And lastly, a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary, so add up to 180 degrees. Make sure to go online, do your flexion, get the bonus point, answer a couple questions, and ask any questions you might have. And we'll see you in class tomorrow.